In this video, we will focus on the nature of roots and its relationship with the discriminant. So this is the relationship that all of us should be familiar with. So there are three cases over here. So what we see is when the curve cuts the x-axis at two distinct points, then we will see that the discriminant is greater than 0. Likewise, when the curve touches the x-axis at one point, it simply means that the equation has two equal roots, and hence the discriminant is equal to 0. And the last case, it will be when the curve does not cut the x-axis at all. So it is either completely above the x-axis or it's completely below the x-axis. So in such case, we say that the equation has no real root, and hence the discriminant is less than 0. Now, so previously we discussed in question 2, and we know that the relationship between the quadratic curve that is lie completely above or below the x-axis, we know the conditions. So the conditions that we are talking about here, all right, it is either if it's above the x-axis, that means we know that a is less than 0. And we also talk about the second condition will be the minimum value of the curve has to be greater than 0. So similarly, if the curve lies completely below the x-axis, then we will need to indicate that the coefficient of x squared, which is a, has to be less than 0. And the maximum value of the curve is actually negative. So this was what we discussed in question 2. So over here in this particular chapter, we will see this. All right, we will see how we can use discriminant to actually do the proof. So over here, if you look at the discriminant, what we see is, all right, the conditions for the curve to be always positive or always negative. So over here, you notice that the two conditions is basically if the curve lies completely above the x-axis, it is the same meaning as the curve is always positive. So in such case, we know that a, which is a coefficient of x squared, has to be greater than 0. And in this case, because the curve does not cut the x-axis, so therefore discriminant must be less than 0. So likewise, if the curve lies completely below the x-axis, then we know that the curve is actually always negative. So in this case, therefore the condition has to be the coefficient of x squared must be less than 0, and the condition of discriminant is still the same, is less than 0. So over here, what we would like you to observe is to note the two similar conditions, all right, that we apply in the previous chapter, in chapter 1, and right here in chapter 2. Now let's see how we can apply this particular concept for the exam question 6. So in this case, we want to find the range is given that it is greater than 0. So in this case, when it is greater than 0, all right, you will need to take note that if it's greater than 0, it simply means that the curve is always positive. So in such a case, if it is always positive, all right, the misconception will be a lot of students will just simply follow the inequality sign. They just simply, because they say it's greater than 0, so therefore they also state the condition discriminant is greater than 0. But if you know your work, all right, you will be able to observe this, right? You must know that, we are actually applying case 3 here, the third case. So in the third case, what you will see here is this, because it is, if it is greater than 0, it's always positive. So that means we are looking at the left side of the graph, which means the curve is always lie completely above the x-axis. So in such case, we know that the curve does not cut the x-axis, and therefore the equation has no real roots. So in this case, the condition for the discriminant, it has to be less than 0. So given this knowledge we are going to apply. So which means right now we know that discriminant has to be less than 0. So we are going to apply this. The other knowledge that you need to know will be how do you identify the B and what is A and what is C. So in this case, if you take a look, you will know that A is simply equals to 1 and your B will be negative bracket P plus 1, which is the coefficient of X, whereas the C here will be simply just P plus 9. So given this, let's apply and substitute the values of A, B, and C into our discriminant. So with this, I would like you guys to observe, all right? So the common mistake done over here will be this coefficient of X, negative B plus, negative bracket P plus 1. Many students, what they did was they just simply ignore the negative sign, yeah, when they substitute the coefficient of X into the expression for discriminant B squared minus 4AC. So this is where you will need to actually pay attention to. Now, so once you derive at the quadratic expression here, the quadratic inequalities, and you proceed applying the skill in solving quadratic inequalities. So in this case, we'll just go through the step again. So what you have is a positive quadratic graph. So I will have, by using graphical method, this is my X. So I'm going to sketch a positive quadratic graph. So the two values that I have here is negative 5 and 7. And since the inequality sign that we have here, all right, it is less than 0. So if less than 0, it simply means that we are referring to the bottom part of the graph. So if we are referring to the bottom part of the graph, so therefore the inequality, the range of values of X that satisfy this inequality, it will be within this range. And hence, the result for this question is P is between negative 5 and 7.